Hello students, in this video I will discuss the infinite series chapter, in which I will cover the examples on alternating series using Leibniz test for testing those given examples, which is the syllabus of BSc 4th semester paper 1 mathematics in Karnataka University, Dharwad. So we will cover more examples on alternating series and Leibniz test for alternating series. So let us see those examples here. By taking example 1, test the convergence series of minus 1 power n minus 1 by n, wherein that n term of this series is actually by seeing this, observing this series itself is alternating series, so that we need not check it or we need not say that it is an other than alternating series. So that n term of this series is an is 1 by n here, and n plus 1, n replaced by n plus 1, it becomes an plus 1, that is 1 by n plus 1. Now when you compare with these two here, that is n plus 1 and n plus 1, usually we are seeing that an plus 1 is less than an. That I wanted to test the first condition for Leibniz test in the alternating series. So that's why I am taking n plus 1 greater than n, or else inversely we have that is 1 by n plus 1 is less than 1 by n. So obviously this is an plus 1 is less than n. And also we check the condition for another condition for a Leibniz test. So that is an equal to limit of the an, means what, limit of 1 by n, as n approaches to infinity it is obviously it is 0. So by Leibniz test, once these two conditions, one is an plus 1 is less than an, another one is limit an, as n approaches to infinity it is 0, then we conclude that by Leibniz test the given series is convergent. And in the second example also it is terms given other than, that is directly they have given the n term. So that test the convergence of 1 by 2 minus 1 by 2 square plus 1 by 2 cube minus 1 by 2 power 4, etc. Means anyway these are the alternatively positive and negative terms, and also this is the increasing the power of 2 in the denominator of that series. N term of this series is an, that is 2 power n. So obviously this is 2 is increasing this power in the denominator of that series. So n replaced by n plus 1, an plus 1. So now I wanted to see that 2n plus 1 is greater than always 2n, but if you take inverse of these two, obviously it's in reverse there, 1 by 2n there. So less than 2n. So that 1 by 2n, so which implies an plus 1 is less than an, and limit an also we check this limit an as 1, that is limit of 1 by 2 power n, as n approaches to infinity it is also 0. According to Leibniz test, once these two conditions are satisfied, the given series is convergent. And in the third problem also, which is increasing, it is a p series, so that where p is positive, so that it is a geometric series 1 by np, but wherein those terms are alternatively positive and negative. N plus 1 term is n plus 1, that is 1 by n plus 1 power p. So that when you have that is n plus 1 greater than n, and you take a power of p on both sides, which is n plus 1 power p greater than np, and which implies if you take a reciprocal of these two terms, inequality, it becomes, that is the less than here 1 by n power p that. So that obviously first condition for this here n plus 1 is less than n, and also another condition for Leibniz test, limit an as n approaches to infinity, that is limit of 1 by n power p, if you take as apply that is limit as n approaches to infinity, this becomes also 0. Both the conditions for Leibniz test are satisfied, so that by this test the series is convergent. And another example, that is test the convergence of this 1 by 2 cube minus 1 by 3 cube 3 cube, etc. 1 plus 2, 1 plus 2 plus 3. So that is, see that series is increasing its nature in its power there. But only thing is 2, 3, 4, that means n plus 1 power cube, and this power is same throughout that. And this also we have, that is 1 plus 2 plus 3 plus 1 n. That means we have, that is if you write it in the n term of that is n, so that n into n plus 1 by 2 that. So obviously n plus 1 gets cancelled, either n plus 1 whole square, and if you take n replaced by n plus 1 in an, so that an plus 1 we have this, and just the difference of these two, an plus 1 minus an, so that is what we have simplifying all the terms, and then finally it would be arrived at less than 0, because since it is c, keep remember that, so that is in the power, in the denominator its power is increasing, that's why it's less than 0, an plus 1 is less than an. Also we have another condition for limit test, limit an as n approaches to infinity for this an, so that n by n plus 1 whole square. Obviously if you take n square outside in the denominator, n1, n remains at the denominator, 1 by n infinity is 0, so that both the conditions for limit test satisfied, so then given series is convergent. And also we have in the last fifth example, test the convergence. Obviously these are the terms are in the arithmetic progression, so that n term of this alternating series are, that is the an is 2n minus 1 by make use of a plus n minus 1, where a is the first term of the series, d is the common difference throughout the series. So an is 1 by 2n minus 1, and an plus 1 is 1 by 2n plus 1, and you can check the conditions for Leibniz test, so that both the conditions are holds here, so that this given series is also convergent by Leibniz test. And test another one here, again you take here also an and an plus 1, and first before that you can write the n term of an, n term of the series, and the n plus 1 term of that an, so that we have there, and check it conditions for first condition for Leibniz test, an plus 1 is less than an. Obviously it holds then another condition for Leibniz test, limit an as n approaches to infinity, it is also 0. So therefore by Leibniz test the given series is convergent. And another example for it is converges absolutely or not, but thing is that it is absolutely, it is first of all, moreover it is, and that is the it is the minus 1 power n plus 1, so that which converges absolutely, even though it is alternating series, but series converges absolutely, as already discussed in the previous session. So as same as we have there, is also alternatively absolutely convergence problem and conditionally convergence problem, already we have discussed in the previous lectures. So thank you. And before we have that, what we have recalled here, so alternating series and examples of Leibniz test for alternating series, we have discussed that, and these are the references we have. Thank you.